So in here, if you remember, if we type the ls min array, let's see, it will show you a lot of like d, r, w, x. So it's all have some explanation there. So let's start from here. We can go to the shell lesson data and try to ls minus la. So here, the first one is the file type. So if it's only test, then it's not a directory. But if it's D, then it's a directory. Let's see from this one, the txt file here, it starts with test, which means this two is just a file and not a directory. And any of the other start with D is a directory. For example, this one, this two is also a directory because it starts with D. And the first three, we call it like binary here. The first three slot is the owner. So R is the permission to read, W is permission to write, X for the execute. Is it like executable or not? So these three determine the permission that the owner have. For example, if the it's only have the R and W, so for example, this file can be like read and written by the owner, and the other three here will be for the group permission. So the other group can only read this file. And the last one is like the others permission, what the other user can see to the file. So in this case, the other people can only read the file. So let's check in this one. So if you see the text number1.txt, it's a text, not a directory. And the owner, which is me, I can read and write. And txt file is not executable because it's only text file. And then the other 3 digits is for the group. So the people that have one group with me can only read this file, but cannot write or execute the txt file. So they cannot change or make any changes into the txt file. And the last one is like for the other group, they can also they can only read, but they cannot write too. So that's it for this one. And to change the permission, we need to have the chmod. And we have several, we have a reference, operator, and modes, and the file name that we want to change. In this one, I have some shortcut to make it more easier. Let's just share you in the chat. So this one is like the Unix permission calculator. So if you're not familiar, for example, okay, for example, I want to create the txt file is executable, and let's have a try. So we just tick the owner, tick all the permission that is required, and then we click calculate here, and you get the 700. So 7 here is have the symbolic called RWX. 7 means like you get the full permission. You can read, you can write, you can execute. But the other group and the other people, we don't specify any rights, right? So we make it 0. 0 means like all, like none of the permission is given. And if we want to have the other group to be able to read and write, we can just tick, and others, for example, read and write. Just need to calculate. So if you see 766, so 7 is the same, like the owner is 7, full permission. And then the groups, they have the R and W, so which is 6, and it's the correct. Also, the same with the others. So we can have a try with change the permission for the txt file, but let's try without any executable because it's a text file. So we want to change the file permission to read and write for all the users. It's also discussed here on the octal permission. It's more easier rather than you use this one. Basically, it's the same, but yeah, so it's more simpler. So I suggest using this one. So let's have a try. Mm. Let's win LA. So we can see we have this one. So what we did is chmod, and then we see what is the calculator. So 666 text1.txt, and we do the ls minus la. And if you see now, it's already changed the permission from the other. Previously, they only read, and the group also can only read. Now they can read and write for the text one. So that's how you change the permission. And then yes, the exercise is the same, like we just do it. You can try on any text file. And that's it for the recap. You just need to do the ls-la to see what is the permission. And if you want to change, just put the chmod, and you can see the calculator here based on the octal. What permission do you want to give for the group or the other owners or the others' permission, and calculate, and you can put it in the chmod command.
Getting started with shell scripts. So our objectives are going to be to write a shell script that runs a command or series of commands for a fixed set of files, then run a shell script from the command line, write a shell script that operates on a set of files defined by the user on the command line, create pipelines that include shell scripts you and others have written. So now getting started with scripts. We're finally ready to see what makes shell such a powerful programming environment. We are going to take the commands we repeat frequently and save them in files so we can rerun all those operations again later by typing a single command. For historical reasons, a bunch of commands saved into file is usually called a shell script, but make no mistakes, these are actually small programs. So not only will this make it faster, you won't have to retype the same commands over and over again and be worried about making mistakes like typos. And when someone comes back to look at your work, they'll have this script that has basically all of the stuff that you were doing saved, so they can just have a look at it and realize, oh, they were doing this. So let's start by going into molecules and creating a new file called middle.sh. So if we are in molecules, pwd, yep. So if we type in nanomiddle.sh, and we want to run this command, copy that across, paste. So this is going to take the the top 15 and then the bottom of those 15, the bottom 5 of those 15, so from 10 to 15. If we save that. So this is a variation on the pipe that we created later. So you got to remember that we haven't run this command yet. It's just being saved in this script. So then if we type in bash, oh, my bad, I didn't tell you how to save this file. So you can do Control O, and then it'll ask you if you want the file name to write to middle.sh. Yes, you click enter. So it says that it wrote one line to that file, and then you can do Control exit, X for exit. Another way to do it, the way that I usually do it, is just doing control exit. Oh, my bad. So if I, let's say, make some changes, that, and then I do control X, it says save modified buffer. And then if I type Y, it goes, yep, file name to write, middle.sh, and then I click enter, and it saves that for me. So now if we do bash middle.sh, it will give us those last few lines that we were looking for. So now moving on, you can also avoid to run your script with bash middle.sh every time if it's getting too tedious. You can type in chmod a plus x, so like Aditya was saying before, there's just another way to specify the permissions that you want to give to the file, and then middle.sh. So once we do that, you can just type /, so that's just saying in the current directory, and then middle. Oh right, I can't tab complete that .sh, and that runs it for us. I think that's pretty much it for running your scripts in a different way. So now, if you want to make your scripts more versatile, so what if we want to select lines from an arbitrary file? We could edit middle.sh each time to change the file name. That would probably take longer than typing the command out again. In the shell and executing it with a new file name. Instead, let's edit middle.sh to make it more versatile. So again, we can type nano middle, hop into here. Then instead of just having the numbers set, oh, sorry, not the numbers, the file name set first, you can type in quotation marks, $1, keep the rest the same. So inside a shell script, the $1 means the first file name or any other arguments on the command line. So when we're going to run our script here, bash middle.sh, first we're telling bash which script we want to run, so that's middle.sh, and then $1 corresponds to the first argument. So in this case, although it seems like Octane is middle.sh is the first argument, it starts off with 0, so 0 is always going to be your bash script, and then from 1 and onwards, you'll be able to put in more arguments. So if we save that, Control O, enter Control X, and then we again type bash middle.sh, and then let's say Octane. It'll give us this, but if I click up and then change the name of the file, so pentane, and now we have a different output. Yep, if you check the numbers here. So looking at the double quotes around arguments, for the same reason that we put loop variables inside double quotes in case the file name happens to contain any spaces, we will surround that $1 with double quotes, just again if your file contains those spaces. Currently, we need to edit middle.sh each time we want to adjust the range of lines that is returned. Let's fix that by configuring our script to instead use 3 command line arguments. After the first command line argument, each additional argument will be accessible via the special variable $1, 2, 3, and those refer to the first, second, third command line arguments. So if we go back in, so I'm just pressing up to get to middle.sh again. And now, I was skipping ahead before, so let me just explain this. So $1 corresponds still to the name of the file that we want to give it. Now $2 is going to correspond to the number that we want to get the head values from. So again, in quotations, $2, and then the tail is going to be, whoops, in quotations, $3. So now we want to run, oh, it's on the next page. So now we can run the script bash middle as, for example, the first command line argument corresponds to pentane. The second one is going to correspond to 15, and that's what we get for head, and then 5 for tail. So again, this gives us the same thing, but you can also change that. So 6, change that to 2, 1, and you can, yep, change this as well, 14, and even change that to cubane.pdb. Pretty much anything you want. So it's a great tool to make these scripts a lot more versatile. But you do, oh, yep, this is the next point that they're making. So it works, but eventually you're going to leave the script behind, come back later, or someone else is going to come back to your script and go, okay, nano middle.sh, and look in here and be like, oh God, what is, like, what am I trying to do here? What is $1? What is $2? So what we can do is we can use comments. So for example, comments, the way you do comments with bash is you want to start off with a hash, and then you can pretty much type whatever you want. You can type echo hello, and it will not run. So in this example, we'll just paste this. This will tell the next person. So this will select the lines from the middle of the file, and its usage is bash and the name of the file name as the first argument, end line, and the number of lines. Again, saving that. All done. So what if we want to process many files in a single pipeline? For example, we want to sort our PDB files by length. We would type this command. So that's giving us word count -L of the PDB files, and that pipes it into a sorting command that will sort them by number. Like that. So if I run that, it'll sort all of our PDBs by file. So now we know which one's the longest and which ones are the shortest. So obviously alkanes is the longest because we've appended all of the other PDBs into it. So let me just read this quick. If we want to be able to get a sorted list of other kinds of files, we need a way to get all those names into the script. And yep, so the point they're making here is, let's say you don't want to work with .pdbs, you want to work with an arbitrary amount of files that are named different things. We can't use the command line arguments because we don't know how many files there are. But we can use the special variable $@, which means all of the command line arguments to the shell script. So we also should put $@ inside double quotation marks, again, to handle those cases. So now if we go nano sorted.sh, since we don't have this file, it's going to make a blank one for us. And we will just copy this across real quick, paste. So this is sorting files by their length, and its usage is bash sorted file, one or more file names. So here, what we can do is bash sorted.pdb, and also if we go back into creatures, wildcard.dat. So here we're going to run the sorted script that we just made, which is defined here, and we're going to look at all the command line arguments that we give it. So here we're giving it all the PDB files in the current directory, as well as all the .dat files in the creatures directory. So if we run this, it sorts all of these. So that's really cool, I think. So if we then want to list unique species, so let's say Leah has several hundred data files. each of which are formatted like this. So this is the first column, pretty much gives us the date, then the unique species, and then the number of them, I'm pretty sure. So an example of this type of file is given in data animal count. So if I move back, where would I be? CD into, oh, sorry, I'm already in data animal counts. ls. So, oh, I believe my file name is just written a little bit differently, so I'll just animals. You don't have to do this. You will probably have the correct file name. So yeah, animals.txt. So we can use the command cut -d -f to animals. So this will take the second column here and sort that by the unique species. So if we just check what is inside animals, yep, same thing. And if we copy this, paste, oh god, I've lost myself. Yep, that was not what I was trying to copy. So again, Control C to get out of that sticky situation. There we go. So yeah, it's given me all of the unique species. So we're going to write a shell script called species.sh that takes any number of file names as long as command line arguments and uses a variation of the above command to print a list of unique species appearing in each of those files specifically. So I don't know why it keeps doing that, but what we want to do is, so the script to find unique species in the CSV file where the species is the second data field, and it accepts any number of files. So we're going to use a for loop that I was telling you guys before. So for file in the command line, so for any file in the command line arguments that you gave the bash script, it's going to echo unique species is $file. And at the same time, it's going to extract that species name. And let's just say that someone has run a series of commands that did something really useful. For example, created a graph that we'd like to use for a paper. And we'd like to be able to recreate this graph later, but we want to save the commands that we just wrote. So instead of typing them in again, or clicking down and kind of getting them again, writing them to a file, because that'll take a lot of time, you can use that history command that we learned before. So history, and then we'll pipe that into tail-n5, and this will go into redo-3, redo figure-3.sh. Oh, whoops, that's right. I would need to touch redo. Let's just make this simpler, redo.sh. And then if I run that command, redo.sh, it would move my history, but the only the last 5 of my history into redo.sh. So if I look into redo.sh, oh, that didn't work. Not sure. Did I do something wrong, Aditya?
I think you were following exactly the same step by step. Maybe there's a different name.
Yeah, I don't think they're.
Yeah,
I
but
think
the
this is
script
just an
is correct.
example.
Yeah.
Yeah.
Yeah, just the name because it's from the previous year.
Yeah.
But
So
yeah,
okay, that's all good then.
yeah, but the step by step is all correct.
Yep. So yeah, I just tried doing it. But for example, if you did this and you had these 5 commands that you just ran, it would take these 5 commands and put them into that sh script, and then you'd be able to just run that again as a script. So why record commands in the history before running them? So if you run the command history tell to recent sh. The last command in the file is the history command itself. In other words, the shell has added history to the command log before actually running it. In fact, the shell always adds commands to the log before running them. Why do you think it does that? So if a command causes something to crash or hang, it might be useful to know what the command was in order to investigate the problem. Where the command only be recorded after running it, we would not have a record of the last command run in the event of a crash. So it's mostly for the user's benefit. So now looking at Nelle's pipelines for scripting, if Nelle supervisor insists that all her analytics must be reproducible, the easiest way to capture all the steps is in a script. So if we return to Nelle's data directory, so right now I'm in data and she is in North Pacific Gyre. Oh, this is just an example. Okay, so if she were to move in there, she runs the editor and writes the following. So here she is looking for data file in each of the files that you give in the command line arguments. It's going to echo the data files and then bash her previous script goostats for data file into stats data file. She saves this file in a file called dostats.sh, so that now she can redo the following stage of her analysis by typing simply bash dostats and then the two files that are needed. She can also do bash dostats, the two files, word count, and -l. So the output is just the number of files being processed rather than the names that were processed. One thing to note about Nelle scripts is that it lets the person running it decide what to do with the files. She could have written it as just calculate stats for sites A and site B for data files. So for data file in DS2, echo the data files, and then just do the same thing. The advantage is that this always selects the right files. She doesn't have to remember to exclude the Z files. The disadvantage is that it always selects just those files. She can't run it on all files, including the Z files, or on G or H files if she has someone else running the script as well. Ooh. Sorry, I just got attacked by a fly. So looking at some exercises for variables in shell scripts in the molecules directory, imagine you have a shell script called script.sh containing the following commands. So head and $2, $1, tail $3, $1. While you are in molecules directory, you type the following command, bash script $pdb11. Which of the following outputs would you expect to see? All of the lines between the first and the last lines of each file ending in .pdb in the molecules directory, the first and last line of each file ending in .pdb in the molecules directory, the first and last lines of each file in the molecules directory, an error because of the quotes around pdb. So if we move into cd data and then cd molecules, so if we look here, it's likely not going to be an issue because of the names. None of them have any gaps. So this is taking, so how many command line arguments do we have? 0, 1, 2. So the correct answer is going to be 2. The special variables $1, $2, and $3 represent the command line arguments, as we know from before. And the script that it's going to try and run is head-n1, and then the names of all of the files, and then tail-n1 for all of the files. The shell does not expand $pd because it is enclosed by quotation marks. As such, the first arguments to the script is pdb wildcard pdb, which gets expanded within the script by head and tail. So next up, we're going to look at how to find the longest file with a given extension. So write a shell script called longest.sh that takes the name of a directory and a file name extension as its arguments, and prints out the name of the file with the most lines in that directory with the extension. For example, bash longest.sh, shell lessons data, so in exercise data, proteins, pdb. So it will write a shell script called longest.sh that takes the name of a directory and a file name extension as its argument, so that would be pdb here, and prints out the name of the file with the most lines in that directory with that extension. So would the name of the .pdb file in shell proteins that has the most lines? So feel free to test your script on another directory. So for this case, obviously we know that that would be alkanes because it is the longest one. So if we, for example, did it in writing text, popping into the writing directory. So this is a shell script which takes two arguments, one, the directory name, the file extension, and prints the name of the files in that directory with the most lines that matches the file extension. So we're doing the word count that looks at the first and second command line arguments. So it's taking the directory or the file names basically, and then the extension, sorting those, looking at the tail and then the head, and then it will tell you the longest file there. So this part of the pipeline counts the number of lines in each file and sorts them numerically, largest to last. When there's more than one file, WC also outputs a final summary line, giving the total number of lines across all files. We use tail-n and then head pipe, so tail piped into head to throw away the last line. With the full command, we'll see that the final summary line, we can build our pipeline up in pieces to be sure we understand the output. So now looking at script reading comprehension, for this question, consider the shell lesson data molecules directory once again. This contains a number of .pdb files, in addition to any other files that you may have created. Explain what each of the following three scripts would do when run: bash script 1.sh pdb bash script 2. So all the scripts with just wildcard.pdb that will look at all of the files. So script 1 would echo wildcard.wildcard. Script 2 for file name in 1, 2, and 3. Do cat file name. And for script 3, echo $, for all of the command line arguments, .pdb. So looking at that, in each case, the shell expands the wildcards before passing the resulting list of file names as an argument to the script. So shell 1 would print out a list of all files containing a dot in their name. So the argument passed to the script are not actually used anywhere in the script. Script 2, would print the contents of the first three files, because here we only looked at 1, 2, and 3 with the pdb extension. That's it? Yep. Script 3 would instead print all the arguments to the script, so all the pdb files, followed by .pdb, and that refers to all the command line arguments. So yeah. So for example, in the first one, we didn't actually give the script anything. Here we've only given it the first three, and here we've given it all three. And for debugging scripts, suppose you have saved the following script in a file called doerrors.sh in Nelle's North Pacific Gyre date directory. So this is looking for data files in $@ at. So for all data files that are in the command line argument that you give to the shell script, it's going to echo the data files. A bit of a typo there. And it's going to bash goostats like it did before and rename these two files. So when you run it, bash do errors, the output is blank. To figure out why, rerun the script using the -x option. So what is the output that it would show us there, and which line is responsible for that error? So the -x option causes bash to run in debug mode. This prints out each command as it is run, which will help you locate errors. In this example, we can see that echo isn't printing anything. Yep, because we made a typo in the loop, that's right. And the variable dat file doesn't exist, hence returning an empty string. And then to recap, the key points were to save commands in files, usually called scripts for reuse. You can run them by using bash file name. $@ refers to all of the command line arguments that you gave it. 1 and 2 refers to the first and second command line argument after your script. The place variables in quotes. Place variables in quotes if the values might have spaces between them, and letting users decide what files to process is more flexible and more consistent with built-in Unix commands.
Okay, so you can see my screen, right? Yep, I will start the last topics. It's like finding things. How can I find files? How can I find things in files? So we test it by first we go to the shell lesson data, exercise data / writing. So we go to shell lesson data, this. And then we go to the writing. And we find hiq.txt. We can see by using cat. And this is all the content that we have inside of the hiq. And we can search using grep command. So this is the UI. If you want to read what is the command, it's like the help, but this is a web page. It's more easier if you want to see. So you can find patterns in file using the regular expression too. So we're gonna grep not in the hiq.txt. If you see, we can find like not here, not, and not. So that's the basic thing. If you want to do the search using grep, we can also try to grep the. If you see here, not only this one, but thesis have the same pattern. That's why the grep also show this one. But we can later filter out. Using the grep flex. So we can put the W option. So with W minus dash W, you can only just take the D one without this one. So it's like a filter out. It's more to specific output. We can also try to have this one too with -N and see which line it contain the result. So we can see it's like we want to search it in the hiq.txt, and it's showing the line number 5, number 9, and number 10. And you can also try with multiple flags here. So minus n and w. So we only want to have the d here specifically, and which line. And it show the with minus n, it will show which line. Can also have the minus v to invert the certs. Can also try this one. This is just another variation of using grep. Can also grep not only in one file, but in this case we have two txt file. We have the haiku and little woman, so we can test with this one. So if we search yesterday in this folder, we can also find there's also yesterday in the littlewoman.txt, not only in haiku.txt. So grep with -r, it will search the whole directory, containing the same keyword. Also, this one is using regex. It's a bit more complex, but yeah, you can search on internet mostly. What is the syntax for the regex command? But this one is means the first letter, and then the second one have the O. So that's why if you try to search in haiku.txt, all the second word starts with O. Oh, sorry, the second letter starts with O. So let's have a try. Yep, it's just result the same. So with that command, with this regex, you can play around. For example, if I want to use the first letter with a capital Y, just change it like this, and it show every line that start with capital Y. So you can play with this syntax for the wildcards. And the TLDR is just the website that I use. So if you confuse reading with minus minus help, you can just put it here. For example, the ls. So yeah, you can find all the information here, and it's like more good to see. And then recap, yeah, you can use find to find files with the specific properties. Grep, mostly we just use grep, and you can use much help to see, but you can also use the TLDR that we provided here. It's more easy. And then the man command is basically the same with help. It's to show the manual function of the program itself.